In today's video, we're going to get some extra practice using graphing and taking data to help us create a visual representation of it to make it a lot easier for scientists to use. So, tonight you have a couple learning goals. They're going to pop up on the screen right now. The two are turn data from a table into a graph and calculate the slope of a line. We'll talk about what slope is in just a minute, but first we're just going to use this example as what you can see on the board is what we're going to turn into a graph. So I decided to run an experiment. I love fish. As you might have told from me scuba diving, I'm a big fish guy. You might have noticed the big fish in the back of the room too. So what I have is I've got at home, I've got a fish tank, and I was interested one day and wanted to know, how does temperature affect my fish? And I decided that I was going to check what I was going to do to figure out how it affected them was I was going to watch them breathing and how fish breathe as they pump their gills and they pump, 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 pump. So what I decided to do with my experiment was slowly change the temperature and count how many times does the gills of the fish pump every minute. So after doing that, this is what I got. I started at about room temperature, which this is in degrees Celsius, and we'll talk more about that later in the year. But for now, this is just data that you can see. And I slowly dropped and dropped and dropped and dropped the temperature. And what I saw was that the gill pumps changed as I did that. So we're going to make a graph based on this data. So remember, what are the 4 things you need always when graphing? 1, choose your X and Y axis. Now, in order to be able to choose your X and Y axis, you need to know what the independent and the dependent variable are. So in the experiment, when I changed the temperature to see what would happen to the gill pumps, which one would be the independent? Temperature. That's the one I, as a scientist, am physically altering. And where does independent go? X-axis. Always X-axis. So let's write that. Notice that I put the units in parentheses. Units. Very important. All right, that leaves my dependent, which is going to go over here. That variable has units built in, so you don't need to have those in parentheses. That's fine. Sometimes that just so happens to happen. So that one's fine the way it is. All right, next thing you need, number 2, you need to make a scale. So for my temperature, what I'm going to do is I'm going to look at that and say, okay, the numbers range from 7 to 23. And we worked on scale in class, but an easier way to do it is just go by 1s, 2s, 5s, or 10s. And looking at that, I think I'm going to go by 5s. You'll get a hang of it as we go along in the year, being able to pick that out. So our origin down here is always going to be 0. And then we're going to have 5, 10, 15, 20, 25, equal intervals as equally spaced apart as I can. Good. Looking over here, I've got 12 to 125. So that one, yeah, you could go 10s, but I'm going to choose to make it easier for myself going by 25s. So 0, 25, 50, 75, 100, 125. And there, I have my graph set up. I've got number 1 done. I've got my X and Y axis chosen based on independent versus dependent. I have my scale made for both of them. I'm ready to do number 3, plot the data. So let's see. 23, at temperature 23, the gill pumps were 125. I find temperature 23, that's right about here. I find 125, I draw a line up in my head, and I place a point. When temperature's 20, 20, I find 102, 102, I go up and place a point. When temperature is 16 degrees Celsius, gill pumps are 86, so 16 is about right here. 86 is maybe right about there, so I'm going to place a point. When temperature is 11, 11 is right about there. I'm going to be at 40 gill pumps, which is maybe right about there. And then temperature 7, about there. Gill pumps 12, maybe about there. And then I'm going to connect the dots. Cool. All right, look at that. So, good thing to note. Don't connect it back to the origin unless you physically have that data point. It's okay to start a line right in the middle of the graph. That's totally fine. This is perfect just the way it is. So I've got my X and Y axis chosen. I've got my scale. I've got my data plotted. Last thing I need to do is create a title. I'm going to make something creative. So I'm going to say, let's see, how temperature affects the way a fish breathes. Now, anyone looking at that will see exactly what this data is talking about. You're showing me, as you change the temperature, how is the breathing rate affected of the fish? Cool. We've got all four things. This is exactly what you want to see a graph look like when you're done. Beautiful, perfect, awesome. So that last thing I wanted to talk about is slope. Well, what is slope? You remember? Ever used it before? Slope is going to be how steep the line is. And it's going to do something really valuable in science. It's going to tell us a little relationship or a little insight on how these two variables work with one another. And first off, I look at this and I see, okay, lines going up as one increases, the other increases. What is that again? Direct relationship. One goes up, so does the other. And then I'm going to say, okay, in order to find slope, what do I need? Well, slope is rise over run. How much does it change in the y direction divided by how much does it change in the x direction? And this is basically a straight line. So we'll talk about where to choose slope and how to pick that on a line. But for this purpose, all I'm going to do is I'm going to just pick the first point and the last point, because it's basically a line. Not exactly, basically. So this point right here, the coordinates are 23 over 125 up. The coordinates down here are 7 over 12 up, which are also right here and right here. So it is possible to do slope directly from the data table. And then rise over run would be, well, what's the change in the rise? So change in the rise would be 125 minus 12, because you went from 12 up to 125, over, and you could count it all the way out, 23 minus 7, because you went from 7 over to 23. So it's that range right there. It wouldn't be a change of 23, because remember, there's a 7 right here left out in the gaps. That's why you subtract the 7. And it wouldn't just be 125, because you have 12 less down here that you want to subtract. So that ends up becoming 125 minus 12 is going to be 113. 23 minus 7 is 16. I'm going to point out right now that there are, since these are measured values, they have a certain amount of sig figs. So here we have 3, here we have 2. Our answer is going to need to have 2 significant figures. You pop it into your calculator. I have an imaginary one here, but I did it before this video. So You end up with 7.06, but because you need 2 sig figs, you need to round that to a slope of 7.1. And that's your slope. That's roughly how steep that line is. And something interesting to note, what are the units of this top part, the rise? They're the gill pumps, right? Let's just say GP. What are the units down here? They're degrees Celsius. So this down here becomes gill pumps per degree, gill pumps per degree Celsius. That number basically tells us how many gill pumps the fish is going to change as I change it by every single degree. We'll talk more about that in class, but it's a very, very useful tool in science. It actually makes a lot of things click. So, hope that helped you guys a little bit more with graphing. We'll keep on working on this in class, and I will see you later.